My apologies for any mistakes I make in advance. I don't feel quite right, so not sure what's going on. I'll begin with a word of prayer. So, Dearly Father, we thank you for this day, for the weekend that's about to start. Just guide our steps today. Help us to understand a little bit more about functions and about how to understand them and work with them, Lord. In your name I pray, Lord Jesus. Amen. Amen. All right, so I promised Michael another example of the simplifying laws of exponents problem, so let's start with that. I am sure many of you could use another example of this. So our goal is to simplify into form c x to the a, y to the b, and identify c, a, and b. All right, so here we go. I'll make us something up. So suppose we've got the fourth root of, I don't know, 81 times x to the eighth times y squared. All of that times x to the minus 1 square root of y divided by the cube root of x to the minus 2 y times the square root of y times x to the minus 3. There we go. That seems hideous enough. I'll give you guys a second to internalize that. Meditate upon it. In fact, I'll give you guys a minute. See if you can simplify it yourself. All right? In the meantime, I will clean this disgusting board over here. Okay, it's not that disgusting. But I need something to do. And how do you keep those sneakers so white? Impressive, impressive. All right. So anybody see anything easy we could start with on this? Yeah?
Can you eliminate the y?
Eliminate the square root of y because we got one here and we got one there. That sounds like a really nice opening move. Yeah, we can do that. Then, oh well, I tried. We can look at that. That's the fourth root of 81. And then the fourth root of x to the eighth, right? And instead of writing fourth root, let's write it as what? X to the what? X to the 8 over 4, right? Because that's the fourth root. And then we've got y to the 2 over 4, because we're taking the fourth root of it. Then I've got x to the minus 1. Let's see here. Now downstairs, I have x to the minus 2 to the 1/3 power, right? And then y to the 1/3 power. The square root of y we canceled out already, and we've got an x to the minus 1/3. Now, what is x to the minus 2 to the 1/3 power? How's that go? That's x to the what? X to the minus 2 over 3, right? So we can look at this term like that. And let's finish it, all right? So let's gather everything together. What is the fourth root of 81? 3. Yeah, that's 3. So we've got 3. Then we've got x. All right, what's 8 divided by 4? That's 2, right? So I've got 2 minus 1. And then downstairs I've got minus 2/3, right? But because it's in the denominator, I do plus 2/3. And then this minus 3 gives me a plus 3. So these two terms here, right? They're coming from this piece and that piece. Because they're in the denominator, when we bring those powers of x to the numerator, we get plus, right? They minus flips to plus 2/3 and plus 3. Okay, that's it for the x's, right? That's all the x's. This problem's got more x's than Taylor Swift. Let's see here, y. Sorry, so like there's so many of those jokes to make. Like it's just.
I think that's the second time.
That's my second Taylor Swift joke. Well, hey, UNC is pure evil. Taylor Swift is just, yeah, whatever. And Michael, am I right or wrong about that plus 1/3? What do you think?
Plus 1/3. Oh,
What was that?
You're wrong. Minus 1/3. You're wrong. Minus 1/3.
What was that?
You're wrong. Minus 1/3.
Michael says I'm wrong. Minus 1/3. I am agreeing. Why is it minus 1/3? Because we have this division by y to the 1/3. I thought it was like a scorpion or something. I was like, you guys know about the Lynchburg scorpions?
No. What?
I just made them up. Let's see here. So, I mean, when I first moved here, I found a black widow at my house, and I was like, whoa. Because black widows are like this amazingly rare thing in upstate New York where I grew up. Like I was always looking for one. I wanted to see one. I read about them in children's books, you know. And then I moved to here, and I found one. I was like, oh no. So I put it in a jar carefully. I brought it to the biology department. I was like, I found this black widow, and they're like,
Okay.
and then after I found about another 20 of them at my house, I understood, you know. Although where I live now, there's not any. So it's mostly Lynchburg. Like Lynchburg's worse. So what is 4 plus 2/3? 14/3. Thank you. And then y to the y. What's a half minus a third? That's a sixth. That I can do. All right. So it's been simplified. Now, final step, identify what C, A, and B are.
Professor.
Yes, Michael.
So if these two are the same, then cross them out.
Yeah, if you have the same thing upstairs and downstairs, you can cross out. Another thing you can look for as a nice thing to simplify is if you have like the fourth root of x to the fourth, then that's just an x, right? Or the cube root of y cubed, that's just a y. Like that's another nice simplification you can make if you see it. But anyway, what do we have here? So C is equal to 3, A 14/3, and B is equal to 1/6 if we just compare this with C x to the A, y to the B. So we don't emphasize this enough, but actually matching patterns is a big part of being successful at algebra. This is even more true if you go on to calculus. Like half of the battle with calculus is knowing your enemy. Like you need to know what it is you're trying to differentiate or take a limit or something. So understanding these patterns and like, it's a lot of what we do. All right, enough about that. Any questions before I go on here? Yes, Michael.
Can you help me solve examples of the problems that don't appear in the textbook?
You'll have to be more specific. You talking about the mission?
Like you did before.
We're about to start into this material, so it'll happen. Okay, so, So, let us talk about functions. All right? So I'm going to talk about functions in a slightly abstract way. This is probably not in your book. And I probably won't even have any direct homework about this. But just humor me here for a minute so I can talk about the concept of it in a way which I think is fitting for what it is. Now, textbooks usually say there's like 4 ways to define a function, and they'll give you like a graph, a formula, a table of values, and I guess the other thing is a picture. But when I think about a function, the language I think about is this, guys. I think about f. So here's the notation, a to b. So what this means is f is a function from a to b. That's how that's read. Now here, a and b are sets. All right, a set is a collection of elements, right? And so to be more specific here, this particular function, it would be, this is a b valued function of a. So the values of the function happen in b. So there's 2 things that are going on here. There's an input and an output, right? You can think of it like this. Here's a, right? Over here is b. And what f is it's a mapping that goes from one thing to the other. So what happens is you have x over here, all right? And the function takes x and it maps it over here to y equals to f of x. So here's the main rule. If f is going to be a function, first of all, it has to make an assignment of where x goes for every element of a. So a is called the domain. Domain of f, or sometimes I'll just abbreviate that, domain of f, right? And so every element of the domain, you have to give a rule for where it goes to. That's the one thing. The other rule is that if you give me an input, there has to be just one output for that input. All right? So it has to be quote-unquote single valued. Yes, Michael?
And the y is the range of that.
That is almost right. And I sometimes say why the b here is actually what's called, technically speaking, it's called the codomain of f. Inside the codomain, there is the set of values which are actually reached, which are actually attained by the function, and these are called the range. So like the range would be something like this, for example. This might be the range. But you're right, Michael, that y would be in the range. So the range of f is equal to all the values in b which are, let's say, attained, which means, is it just a fancy word for saying they're actually reached, okay? Now, a lot of times in a given semester, I might even the word codomain might not have even escaped my lips to you guys, okay? So I never test on this codomain. But there are reasons that you want to talk about a set over here which is larger than the range. But anyway, I won't test on that. Okay, so this is just kind of an abstract picture. How do we actually define a function in here? So our context, what's our context? All right, so our context is, look at real valued functions of a real variable. So this funny looking R I just wrote is just another notation for the whole number line. That's just minus infinity to infinity. So how can we define a function? Like, how do you define a function? So I also like to think about this picture. So I think of the function as like a machine, right? Here's f. And what does it do? You feed it an x, right? X goes in, and what comes out? Y, but more specifically f of x, right? And so if I know the formula, for f, that defines the function, right? That's kind of almost true, but technically speaking, to really define the function, I also have to say what are all the possible inputs. I have to state the domain for the function. So so the way we can define it is one, with a formula, f of x, all right? We can define a function with a formula. Now, if we just do that, if I don't, well, we can define a function with a formula, and we can say domain of f of x equals fill in the blank, like whatever. You just tell people the domain, all right? That's one thing you can do. But the other thing, the thing we usually do, guys, is we just say, give the formula. We give the formula f of x, and the domain of f of x is decided by, let's say, greed. What kind of greed am I talking about? Number greed, in the sense of we want all the numbers we can have. So you define the domain of the function in terms of like what's the maximal set of x's which make the formula make sense. All right, that's oftentimes the default. That's the default domain. The third thing, and I think of 1 and 2 almost as the same thing, but the third thing is we can define function by a graph. Now, what's a graph? Let me give you a definition. Graph of a function is equal to x comma y such that x is an element of the domain of f and y is equal to f of x. Now I use some math language there, so I'm going to put it into plain English in just a second, but let me move my camera and then I'll get back to the board. So this is another way to look at a function, is it's defined by its graph. And we could draw a picture for the graph, right? Like, we don't have to give a formula. I could draw a picture and you could try to decide whether or not that picture was actually an honest to goodness function or not, right? So what does that funny looking E mean? Do you guys know?
Element.
Element of. Well, you guys are doing better than my calculus class. That's good. Let's see here. So element, x is an element of the domain. All right. So I'm not particularly interested in the other ways to define a function is by like a table of values or by a picture. I never use those in here pretty much ever. So let's just skip them. Focus on what matters most. All right. So Let me give you 3 examples to illustrate all 3 definitions, okay? So for each example, we're going to try to decide what's the domain and what's the range, all right? So example 1. Let's suppose that f of x is equal to x squared, and the domain of f of x is given to be -1 to 2. My question for you is, and this is a very stupid question, what is the domain?
-1.
It's -1 to 2, right? Because why is it? Because I said so. All right? This is something you can do. You can just state the domain. All right? What's the range in this case? Well, range is trickier. I need to graph this thing. How would you graph a function? You're looking for where y is equal to f of x, right? So I assume you guys have had some previous experience with the Cartesian coordinate system, right? You know what x means, you know what y means. If that's not the case, please read the sections in the text that are about this, review for yourself. But we can like plot some points, right? So what is f of -1 equal to? We do -1, we square it, that's the formula. So f of -1 is equal to 1. What this calculation means is that the point -1, 1 is, on the graph. Right? Let's do a few more of these. How about f of 0? What's f of 0 equal to? Well, 0 squared, also known as 0, right? So that tells me that the origin is part of my graph. I can also plug in, what's another good number? Yes, Michael?
5.
5? Oh, a good idea. But the problem with 5 is it's out of bounds.
Oh.
5's not allowed. Why?
1.5.
Because I said so. 1.5. Now you're making work for me. All right, f of 1.5 it is then. Now everybody knows that 1.5 squared is 2.25, right? So that means that the point 1.5 comma 2.25. Why'd you do that? Michael, why'd you do this to me? All right, 2.25 is on the graph. How about f of 1, though? We can also do that one, right? That's 1 squared, which is 1. So the point 1 comma 1 is on the graph. Where's 2? What's f of 2? F of 2 is 2 squared, which is 4. That tells me that the point 2 comma 4 is on the graph. All right. This is definitely overkill. We didn't need this many points. And in fact, I would like for us all to get to the point eventually where we don't actually have to plug in points. That this is one of our standard examples. We just know the shape of it and we write it down. Right? So like -1, 1 would be here. That's that point, right? The origin is here. 1, 1 is over here. Michael's 1.5, 2.25 is roughly here-ish. And then 2, 4 is like here. I don't know, I'm not very good at that. Anyway, so up to the limits of my artistry, the graph looks something like this. Actually, we know how to graph this already. What am I talking about? We've done this already. I shouldn't have had to do all this for you guys. This is part of a parabola, right? Y equals x squared is a parabola. This is the parabola that has the vertex, which is the origin. You guys know how to graph that already. We talked about this. So all I'm doing is really restricting that graph to the where? Just from -1 to 2. Now, we need to do this. See, the question of what the domain was, well, that was kind of stupid. I just told you what the domain was. What's the range here, though? Yes, Michael?
Oh. The range is y. Y.
In terms of an interval, can you tell me the range? Yeah. 0 to infinity, is not right for this example, but maybe it'd be right for the next one. Example 2 is just going to be f of x equals to x squared. But let's finish example 1. So what's the range? Yeah? 0 to 4 would be correct. And the reason for that is those are the value. See, this right here is y equals to 0. That's the lowest value, right? This up here is y equals to 4. So the values which are actually attained, if you just think about slicing through your graph with horizontal lines, you only get something if you go from 0 all the way up to 4. Past that, there's nothing. Below that, there's nothing. So the range is just 0 to 4. Okay? So there's that. Now, example 2 is just f of x equals x squared. So what's my domain now? Yes, Michael?
Never mind. Go
Okay.
ahead.
Anybody else? Domain. Let me restate it in a form that's easier to answer. What is the set of all x for which this formula makes sense? Let me state it in a different way. Is there any x which this formula breaks for? Can you square a negative number? Sure. Can you square 0? Yeah. Can you square a positive number? Yes. That's all the kind of numbers there are. So we're good.
Real numbers.
All real numbers, right. The domain here of f of x is just minus infinity to infinity. And the given problem, right, the problem, this was what was given. This we deduced by greed, all right? Mathematical greed, number greed. It's okay, right? Let's see here. Then we can graph this, right? What's the graph look like? I'm not going to plug in points because, hey, we already know the graph y equals x squared, right? It is a parabola. The vertex is here, and it goes on and on, right? This is y equals x squared. What's the range then?
This one is 0.
Yeah, this one's the 0 to infinity you were thinking about.
Yeah.
And so like the range of x squared, if you like, is 0 to infinity. We could write that. We good? So that's an illustration of the first kind of definition. That's an illustration of the second kind of definition. Let us go on to case 3. And so here, I'll try to make it big. This point right here is minus 3 comma minus 4, let's say. All right. And then right here, I'll make this an open circle. And that's going to be at the point 0 comma 1. All right. And then over here, this point up here is going to be at the point 2 comma 3. And then finally, up over here, I'm going to have the point, let's say, 6 comma, I don't know, 7, just for the sake of discussion. All right? And then I'm just going to connect the dots here, guys, a little bit. So I'm going to do a line from here to here, right? And then a line from there to there. So this defines a function. Of course, I do need to write over here y equals f of x. That just tells the reader this is the graph of f of x. So every point on the picture tells me the value of the function, right? For instance, from this point 0, 1, what do I learn? F of 0 is what? It's a trap. So the answer is you learn nothing because it's an open circle, which means that 0 is not actually in the domain. So this we'd say does not exist. So I started with a weird point. My bad. How about this one down here? Minus 3, 4. What can we say? F of minus 3 equals to what? Yeah.
F of negative 3 equals to negative 3?
Negative.
Oh, negative 4.
Negative 4. You probably just couldn't see it. I'm sorry, Michael. I'm too far over here.
Ah.
How about this one up here? What's this say? This says f of 6 is equal to 7. So every coordinate on a graph for a function tells you an input and an output. The input is x, the output is y. Right? All right. Now for my question. What is the domain in your favorite interval notation? So I'll start us out here. We go from minus 3 included all the way over to 0 excluded. And then we take the union with what? Let me change my color coding a little bit here. I'm going to do red for the lower one. I'm going to do blue for up here so we can talk about the difference in color. So I got this is the red part right here, all right? So what x values do you see in the blue line segment? You're going from what? From 2 to 6. So we take the union with 2 and 6, and they're both solid dots, so we include the 2 and the 6. All right, there we go. That's it. That's the totality of the allowed x values from the given graph. That's just that. Okay? What's the range? All right, so I'll start us out. Well, you guys tell me, what we got here for the range?
0, 6.
Ooh. Negative 4 is where we're starting.
Negative 4, infinity.
There's no infinity.
Negative 4.
So let's look at it. We're taking y values from minus 4 here, right?
And the 1.
All the way up to 1. 1 isn't included because that's an open dot. So we do minus 4 to 1, parentheses, union.
And 3 to 7.
I heard a 3 to 7. Are the 3 and the 7 included? They're both included. Now the reason we do 3 to 7 is because we get to 3 here and we get to 7 here in the y. All right? The y values are the range, the x values are the domain. The range is all of the y values which are attained. The domain is all of the x values which are attained in the graph. Do you guys understand? Do you think this would be an easy test question? No? Oh man. Believe in yourself. Let's say that, let us get in our mind that this is going to be an easy test question.
This is going to be an easy test question.
Okay. Because when I typically ask this question, like 40% of the class gets it like really, really wrong. So let's change that this semester, right? This is not a hard question. You just have to keep clear in your mind what's the relation between the x and the y, right? X for domain, y for range. Okay.
Find the relation.
Now, let me go on here. If there are any questions. Yes, Michael. You want me to work some problems like the mission, yes?
Yes.
Yes.
He got me.
Thank you. Don't worry, it's probably just mono. Well, some girl came in my office and she was telling me that she was sitting next to somebody in convo and they got like mono and stuff, and I'm like, oh, yay. Now you're in my office. Hooray. Let's see here. All right, I'm finding my, okay. Don't worry, I probably don't have it. I just feel tired all the time anyway. But let's see here. Of course, that's probably mostly because I've... All right, here we go. Let us go. Let's do it.
Let's do this.
All right. So, example 4. This is pretty simple. Suppose we have y equals to 2x minus 5. Can you identify the function and give the domain and range? So I identify the function. We have f of x equals to what?
Equals 2x minus 5.
2x minus 5. Very good.
Y is the same as f of x.
We can graph this. Easy to graph, right? It's a line. It's got a y-intercept of minus 5. It's got a slope of 2. It looks something kind of sort of like this, right? So what's the domain? What's the range? So what x values are you allowed here? Well, anything, right? So the domain is all real numbers. What y values are reached here? Well, it keeps going both ways, right? I mean, every y value is attained up and down. So the range is also all real numbers. That's it. All right. Now, what's next here? So next problem, I give us the equation xy equals to 2. Can you, this would be the graph of what function? Yeah. If we solve for what?
Solve for,
Yeah, solve for y? 2 what? 2 over x. So your function is f of x. Right. So I'll talk to you guys more about this more systematically as we go on in here. But the graph of this function is an interesting one. It has what's called the vertical asymptote at 0. So notice that you've got this sort of x equals to 0 is not allowed, right? X equals to 0 is not in the domain of the function. And what happens with this function, well, let's think about it here for a second. What happens if you plug in like f of 0.1? What do you get? 2 over 0.1. What's 2 over 0.1? Wow, that's big. 20. How about what about 2 over minus 0.1?
Negative 20.
Negative 20. Right. So what's the deal with this function is it's getting super tiny and super big as we get close to the x-axis, right? And if you plug in if you plug in 1, you get 2, right? If you plug in minus 1, you get minus 2, right? So it goes from 20 to 1. I mean, it goes from 20 to 2 just like that. And so if you put in some more points, you're going to get this shape, basically. It's not. I'm trying, guys. It's not all crooked like that. It's it's more smooth. Do you guys remember? If I did it right, you might be able to see the similarity to something we did before. Do you guys remember this one? Do you remember that? That was a what? That was a hyperbola, right?
Hyperbola.
See, actually, this shape is also a hyperbola, but it's just been rotated. This is actually a hyperbola rotated 45 degrees from... Oh, 45 degrees. What's that? We don't know about degrees in here. What am I saying?
90 degrees.
Do you guys know what 45 degrees means?
45 degrees means...
Okay. Oh, yeah, you know. Okay. Good, good, good.
Oh, it's tilted slightly.
Yeah. I mean, we don't talk about angle measure in here pretty much ever, so my bad. But but I think most people know what 45 degrees means anyway. So anyway, that's the graph. All right. So what's the domain and range here? It's kind of funny. I think it's I think they're equal again, aren't they? See, because the allowed x inputs are what? Everything except for zero.
Infinity, infinity.
Negative infinity, except for 0. So we do negative infinity to 0, unioned with 0 to infinity. And it's the same story for the range, isn't it? Because you go down, 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 and you go up, 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 up. But the one thing you miss is where y equals to 0, right? This is y equals to 0, never attained. So this is actually equal to the range.
They're the same.
Yep. All right, so let's go on here. My next example is a little bit more I'm not sure. Anyway, so listen, the question of domain and range, we'll keep coming back to it, but I'm going on a little bit now more to the mechanics of how we like calculate a formula. All right. So here's the deal. We're given example 6. We're given f of x equals to minus 3x plus 4. And we're also given that g of x is equal to minus x squared plus 4x plus 1. All right? And we're just asked to calculate some various things, like we're asked to calculate what's f of 1/3. We're going to calculate f of 1/3. And then we're going to calculate g of minus x. We'll see if we can do those two things and, all right, see how that goes. These are actually two of the recommended homework problems, if you're wondering. Okay, so yeah. So what do we do? What does this mean? Means we take, and every place where we have an x, we put a 1/3, right? So I do minus 3 times 1/3 plus 4, right? Yeah, which is minus 1 plus 4. So we get 3. There you go. That's all there is to it for that one. Now, how about g of minus x? How does that work? Well, we got to be careful.
-1.
We have minus, and then we put minus x, and we're supposed to square it. Plus 4, and then minus x plus 1. So I put parentheses in like that. And then we can simplify this, right? What does that actually equal to? We've got minus x squared minus 4x plus 1. Let me try something a little bit more symbolic, if you guys don't mind. What would we have if we did like g of, let's say, a plus h? How would that go? What would g of a plus h look like? So let me suggest something here. Maybe this will help you. If you didn't follow what I did in the last example, right? It's sometimes helpful to just take the formula that you have and replace it with a different variable. So I'll use Pac-Man. Wow. It's minus Pac-Man squared plus 4 times the Pac-Man plus 1. That's the formula written in terms of Pac-Man. And so I just have minus Pac-Man squared plus 4 times Pac-Man plus 1, where Pac-Man is equal to a plus h. So then making that substitution then maybe is more manifest. So now if you don't need to do this silly Pac-Man step, then that's fine, but here it is, a plus h squared plus 4 times a plus h plus 1. And if it didn't say simplify, then I'd be like, okay, we're done. But what if I said simplify? What should we do? We would do minus, we've got a squared plus 2ah plus h squared.
4.
Yeah, plus 4a plus 4h plus 1. So it looks like we've got ourselves a minus a squared minus 2ah minus h squared plus 4a plus 4h plus 1. And I, you know, after all that's done, I almost feel like before I multiplied it out, it was better. So if the instructions were, you know, take your answer and simplify it, I'd almost be inclined to leave it as, I don't know, I can't make up my mind. Either is a good answer. The larger point here is that you understand how to symbolically evaluate the formula for a function, right? You can just plug a symbol in the place of x and do it just the same. Sometimes we plug in numbers, sometimes we plug in other expressions, right? Any questions? So those are some of the examples. Those are examples were from section. Oh, I have one more. I have one final example for us, guys. Stick with me here.
I'm hanging with you.
And oh, I didn't top hat yet, did I?
Oh.
You guys are like. I did. Well, it went around. I hope it went around. I got it in the back. So the last question I need the projector for, guys. Come on. Well, hello. Hello.
There we go.
All right, I hope you guys can answer my next question I'm going to put up here so we can leave.
I like your laugh.
You should have given us
Well,
a
thank
solve
you.
problem and have to solve his top hat solution.
Yeah. Wait, don't do it. I thought we were going. I didn't get you. Yeah.
Where'd it go? Oh, here it is.
It's more of an intro.
Ah! Sorry, Michael. Not trying to freak you out there.
Just playing along.
Okay. Good. I'll allow it. All right, guys, so. All right, these are almost unfuzzy enough to read. I need to get a refund on my scanning.
Did your son scan them?
Yeah, he scanned them. I paid good money for these. Like, I paid $10 whole for all these scans. So, so the question is just this: if you've got a graph, can you tell me what is f of minus 2, what is f of 0, and what is f of 1, and what is f of 4? So let's look at this one. You guys tell me, what is f of 0 for this one? f of 0 is,
I can't tell if that's 3 or 4.
that's a 4.
That looks like 3.5 based on what the dots have.
It's a 4. F of 0 is 4. What is f of minus 2? Well, f of minus 2 is 0. F of 2? 0. F of 4? 4. How about this one? F of minus 2 is 5. F of 0? 0. F of 1? 1. F of 2? 0. F of 3? 2. F of 4? 4. All right. Anyway,
That's a good way to look at it.
more of this next week. Exciting, yes? Oh, did I miss a circle? Circle means it's not in the domain.